Hello students, welcome back to SGC online chemistry classes. This is lecture number 5. This is lecture number 5. On the topic classification of elements and periodicity in properties. Well students, from the last video where you will have come to know regarding the writing of IUPAC names, about the IUPAC names of elements with atomic number more than 100, with atomic number more than 100. Till 118, till the atomic number 118, where we have collected a table containing the atomic numbers, the IUPAC names with symbol, and followed by official names. The official names till the element with atomic number 111 is given by the IUPAC system. Then onwards, no official names were given. They are yet to be collected. So that was an idea from the last video. Well, in the today's class, in today's video, let's collect the continuation of the syllabus part from this topic. So altogether, from the earlier videos, from origin of classification of elements till the IUPAC, writing the IUPAC names of element with atomic number more than 100. So we all have got an idea about the periodic table. So in today's class, let's take an activity with the heading how to locate the position of an element. How to locate or predict the position of an element in the modern periodic table or simply periodic table. So let's take some examples. Before we go to examples, let's collect the guidelines. After collecting the guidelines, we will take some examples of locating or predicting the position of the element in the periodic table. Well, the class starts with the title locating or predicting the position, predicting the position of elements, predicting the position of elements in the periodic table. How to predict, how to locate the position of element in the periodic table. The group, the blocks and the period to which a particular element belongs, that can be identified with the following guidelines. I repeat, the period of the element, the block to which it belongs, and the group to which it belongs. The period, the group, and the block to which a particular element belongs can be identified with the following guidelines. So what are the guidelines in getting the period, block and group number of a particular element? Let's take. What are the guidelines? The guidelines are the guidelines in predicting the position of an element in the periodic table. It may be of S block element, P block element, D or F block element. It may be of any element. First one, the principal quantum number. First, one has to take the electronic configuration. First and foremost, we will predict totally based on the electronic configuration of the element, and the electronic configuration where I think you got perfect with the last topic, structure of an atom, where you practiced the method to write the electronic configuration of elements up to 50, more than 50. Come on. First guideline is the principal quantum number. The principal quantum number indicated by n. The principal quantum number of valence shell. The principal quantum number of valence shell that represents the principal quantum number n of valence shell will represent the period of element that will gives an idea about the period of the element to which period it belongs can be predicted with the help of principal quantum number of valence shell when you write the electronic configuration. So n of the outermost shell will decide the period of the element to which it belongs. And the second guideline is the subshell in which the last electron is filled. The subshell in which the last electron is filled, that represents the subshell in which it may be is it a S subshell, P subshell, D subshell or F, the subshell in which the last electron is filled, that represents or that corresponds to the block of an element. That represents the block of an element. So here the simple 3 ideas one should keep, which are called guidelines to locate the position of element in the periodic table. First one, the principal quantum number of the valence shell and writing the electronic configuration. First and foremost, electronic configuration is mandatory. One has to write the electronic configuration of element. No doubt. The principal quantum number in the valence shell, the principal quantum number of the valence shell that corresponds to or that represents the period of an element to which it belongs. Whereas the subshell in which the last electron is filled, the subshell in which the last electron enters or filled, that corresponds to the block of that element. As you come to know from the classification of elements, based on the electronic configuration only, they were classified into S, P, D and F. If the last electron enters into S subshell, it belongs to S block, and P subshell, then it belongs to P block element, like that. Come on. The second guideline is the subshell in which the last electron is filled, that gives idea about the block of the element to which it belongs. And the third, group number. See, group number is predicted or located. Group number is predicted by the number of electrons in the valence shell. Group number is predicted by the number of electrons in the valence shell. Number of electrons in the valence shell. Right. Number of electrons in the valence shell. Number of electrons in the valence shell. From the total number of electrons in the valence shell, we can predict the group number. the subshell in which the last electron enter, we get the block of the element to which it belongs, and the principal quantum number of the valence shell of that element will give the period of that element to which it belongs. So here, so in predicting the group number, we will make use of the table. So with that table help us to easily locate the position of an element. One should remember this table. So what is this block? I write the table consisting of 2 columns. One is the block. How to predict the group number in a particular block and group number. Block and group number. Let's see. S block, as we have mainly 4 block in the modern predictable. How to predict the group number of the S block elements? If the element belongs to S block, how to predict the group? So for the S block, group number is predicted. Mainly the group number is predicted with the total number of electron in the valence shell. Now, for the S block, the group number is predicted by number of electrons, it is the number of ns electrons. In case of S block, which it consists of, where you can see, which it consists of group 1 and group 2. So in case of S block, the group number is predicted with the help of number of ns electron present in the outermost S shell, ns electrons. Second, for P block, you have 10 plus number of ns electrons plus number of np electrons, ns electron plus np electron. In case of P block, how to predict the group number? We have 10 plus number of ns electron plus number of np electron. In case of D block, so the D block number is predicted. In the D block, the number is predicted by number of n-1 d electrons plus number of ns electrons. In the case of D block, group number is predicted by number of n-1 d electron plus number of ns electron. Last, F block, it is fixed. For F block, group number is 3. So I will go through this once again. For the S block, the group number is predicted with the help of number of electrons in the number of ns electrons. For the P block, group number is predicted by 10 plus number of ns electron plus number of np electron. In the case of D block, the group number is predicted with the help of number of n-1 d electron plus number of ns electron. Lastly, the group number of the F block is 3. It is fixed. It is 3. So this table, if you remember, and based on these guidelines, based on these guidelines, let's take some examples of locating the position of element in the periodic table. Let's start with examples. Well, example 1. So what is this? The electronic configuration of element is the electronic configuration. In short, I have written the electronic configuration of element is the electronic configuration of element is, they have given 1s2, 2s2, 2p6, 1s2, 2s2, 2p6, 3s2, 3s2, 3p6, 3p6, 4s1. Repeat. The electronic configuration of element is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. It is given in the example or exercise. What has asked? This is given. Locate the position of element in the periodic table. Locate the position of element in periodic table. So this is the example 1. What they have given in the example? The electronic configuration of the element. They have not given the name of the element. Simple, they have given element without specification. But the electronic configuration of that element is given. If you are perfect with the electronic configuration, and definitely hope one would have obtained which element this electronic corresponds to, which of the element one would have predicted if you are perfect with the electronic configuration. Well, the electronic configuration is given and they asked us or you to calculate the position of element in the periodic table. Position, we have to first identify the period to which period it belongs among the 7. Second, to which block it belongs. And the third is the group number. Well, in the solution part, let's take in the solution part. See, electronic configuration, keeping this in the mind, I write. So, how to predict the period of the block to which it belongs? The guideline says the principal quantum number of the element, the principal quantum number of the the principal quantum number of valence shell of the element will give the period of the element to which it belongs. Now, the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. So, what is the n value principal quantum number of the valence shell? So, the principal, I can write directly, principal quantum number n of the valence shell is 4. Therefore, element belongs to fourth period. Since n value, I can write since n value is 4 from the electronic configuration, since n value is 4, n value is 4 from this data, since n value is 4, therefore this element belongs to fourth period. Then look at the valence shell, the electron in which subshell it is entering, Again, since last electron entering into or last electron is filled in the S subshell. Last electron is filled in S subshell. Therefore, since it is filled in the S subshell, which it indicates the element belongs to S block. What does it indicate? Therefore, this indicates the element belongs to S block. First we have located the period of the element with the help of the given atomic number, with the electronic configuration. It belongs to 4th period since principal quantum number of the valence shell is 4th period. Second, since the electron is entering into S subshell, which electron? Last electron is entering into S subshell, therefore element belongs to S block. Third, group number. As you know, since S block, the last previous table, S block mainly consists of two groups. S block mainly consists of two groups, group 1, group 2. If the number of ns electron is 1, that corresponds to group 1. If ns electron 2, then that corresponds to second group. Now, what about to group? Since only one electron in the ns, since number of ns electron is 1, to the power 1, since ns electron is 1, therefore the group number of the element or element belongs to, element belongs to what? Group 1. Group. With the picture of periodic table, modern periodic table, you can predict. Tell me which element it belongs. Group 1 element of S block, that too in the 4th period. That's going to be checked in the periodic table. It is potassium. The element is potassium. Come on, example number 2. Example 2. Slightly modification. The electronic configuration of the element is, I do change and locate its position. The electronic configuration of the element is, take this one. Electronic configuration of the element is one s2, 2s2, 2p6, 3s2, 3s2, 3p1. Okay. A slight change in the electronic configuration. That's all. Now, problem same. Locate the position of an element in the periodic table. Now try your, put your effort. 1s2, 2s2, 2p6, 3s2, 3p1. Same way. So what is the n value of the n value of the valence shell? Principal quantum number of the valence shell? It is 3. From the electronic configuration, it is very clear. It is 3. So n value is 3. So when n value is 3, that element belongs to 3rd period. Element belongs to 3rd period. Element belongs to 3rd period. Next. The last electron is entering into the p subshell. The last electron is entering into P subshell. Therefore, the element belongs to P block. From the configuration, last electron is entering into P subshell. Therefore, element belongs to P block. Come on. The group number. So, group number for the P block from the previous table. For P block, it is a P block element. Therefore, group number is. So, group number is given by what? For the P block, it is the 10 plus number of ns electron plus np electron. Recall the table. So here look at the electronic configuration. It is a 10 plus. So what are the number of ns valence shell s electron? So here 2 and the np electron 1. So total 10 plus 2 plus 1 13. Therefore the element belongs to 13th group. Element belongs to 13th group, which you can check in the periodic table with 13th group. Electronic configuration 1s2, 2s2, 2p6, 3s2, 3p1. So that element is none other than aluminium 13. So it is group number 13 and the period number 3. Period number 3 and that corresponds to P block. This is how with example 2 we have located the position of element with its period number, the block to which it belongs and the group number to which it belongs. Let's take example number 3. The electronic configuration of element is given argon, noble gas core 3d5 4s1. Locate the position. Practice. So n value is 4. So that belongs to 4th period. Last electron is not entering into a s subshell but is entering into D. Therefore D and it belongs to D block. And what about the group number of a D block element? The group number of a D block element is given by sum of n-1 D electron plus ns electron. n-1 D electron 5, n-1 n4, n-1 3. So this is 3D 5 electron and ns. So total 6. The element belongs to 6th group, which you can look out. The 4th period, 6th group, 4th period and is none other than, so you can check 6th group number 6, period number 4 and the element is 3d5 4s1. It is none other than chromium. So if I change slightly, example number 4, example 4, I'll change 3d8 4s2, 3d8 4s2. Now practice. So n value 4. So the element belongs to 4th period. Since the electron is entering not in the S but in the D, therefore the element belongs to D block. Come on, group number for the D block, number of sum of number of n-1 D electron, ns electron. So what are the n-1 D electron? 8 and ns electron 2. So it is 10. So it belongs to 10th group. It belongs to 10th group. So you can check. So 10th group 4th period element, group number 10 and it is 3d8 4s2. It is the element nickel. So this is how we are going to locate the position of element in the periodic table. Let's take example number 5. Take this. An element is present. An element is present in the 3rd period. In the 3rd period. An element is present in the 3rd period of P block. they have mentioned the block of that element to which it belongs. Third period of the p block, it has 5 electrons. It has 5 electrons in its outermost shell. In its outermost shell. Predict its group. Continuation. How many unpaired electrons does it have? How many unpaired electrons does it have? Come on, read the problems carefully. Example 5. An element is present in the third period of P block. See, in locating the position, they have given the period as well as block. In the previous examples, we have located or identified the period as well as the block of the element to which it belongs. Now they have given period and block here. One more data they have given, it has 5 electrons in its outermost orbit. That element belonging to P block in the third period has 5 valence electrons. Predict its group. There are 2 parts. You have to first identify the group. Next, how many unpaired electrons does it have? There are 2 parts in the solution. Very simple to identify. Come on, I do write. As it is a P block, let me write the group number. Let me first identify or predict the group number. So group number, since it is P, so what the guideline says? The group number of a P block is calculated as sum of 10 plus number of Ns plus number of Np. Number of Ns electrons plus Np electron. So 10. See, altogether they have given it as 5 electrons in its outermost shell. This together is 5. Ns plus Np together is 5. Therefore, it is belonging to 15th group. The element belongs to 15th group. It belongs to 15th. So 15th group, this element belongs. And what is the outer electronic configuration of this 15th group? If I write electronic configuration of 15th group is, outer electronic configuration of 15th group is Ns2 Np3. Keeping this in the mind, Ns2 Np3, there are 5 electrons, yes, in this manner, Ns2 Np3. And check out the electronic configuration. Ns2, it is completely filled. Np3 as capacity of p orbital is 6, it is half filled. Therefore, if I arrange them in the box representation, it is paired up, and here 3 p orbitals, 3px, 3py, 3pz, as per rules, Hund's rule, electron occupy in each 3 of them. Now this is completely filled and half filled 3 orbital. Therefore, unpaired electron, second part. What are the number of unpaired electron? Unpaired electron, which is equals to 3. There are 3 unpaired electrons in the element with given data of 5 electrons in the outermost shell. This is how the problem is. Let's go to the problem number 6 with a slight modification. What I do here? Come on. Example number 6. I do change 5 by 4 electrons. Come on. 5 by 4 electrons. So repetition of the same. So predict the group number and also find out the number of unpaired electrons in the element with 4 electrons belonging to P block, that too in the third period. Problem same. 5 valence electrons replaced by 4. Come on, let's solve this. Group number, you get 10 plus Ns plus Npe. So total how many electrons? 4. So that belongs to 14th group. So the general electronic configuration of 14th group, what is that 14th group? It is Ns2, Np2. Ns2, Np2, 4. Ns2, Np2 means this remains vacant, empty. So this is completely paired up. And how many unpaired electrons are there? So you have unpaired electron is 2 in this case. 2 in this case. Come on, let's take the example 7th one. Seventh example. Example number 7. Take this. This is of different type. Give the electronic configuration. Give the electronic configuration of following elements. Give the electronic configuration of following elements. First one, the third alkali metal. The third, you will be asked a question of this kind also. The third alkali metal. The third alkali metal. Second, the second transition element. The second transition element. Third, the fourth noble gas. The fourth noble gas element. The fourth noble gas element. Fourth one is the second halogen. The second halogen. Let's read the problem. Give the electronic configuration of the following elements. So you are aware to write the electronic configuration with the atomic number or by name of the metal. Here both are not given. They were given in a position of those elements in the periodic table. They have given the position. See, what was this position? I can write the solution part over here. Come on, solution. Solution of all these corresponding to. See, the third alkali metal. You know alkali metals, look at the periodic table. Alkali metals starts with lithium. The first alkali metal is lithium. Second is sodium, and the third alkali metal is potassium. That elements, the third alkali metal is none other than potassium. So the potassium atomic number is 19. So the electronic configuration. So what is the electronic configuration of potassium? You can write with noble gas core or directly as a neon noble gas core. I can write neon noble gas core potassium, argon noble gas core, 18 electron, and it belongs to fourth. The third alkali metal, fourth period, it is 4s1. Or you can write like this: 1s2, 2s2, 2p6, 3s2, 3p6. This is one and the same as argon noble gas core. 1s2, 2s2, 2p6, 3s2, 3p6, same as argon noble gas core, 4s1. So that completes the electronic configuration of alkali metal. Come on, the second transition element. The first transition element begins with the third group, that too with scandium. With atomic number, you can check scandium, third transition element with atomic number 21. The second means it is a titanium with atomic number 22. The element is titanium with atomic number 22. The electronic configuration is, I'll go through the noble gas core. Argon noble gas core, 18 electrons accommodated. Now you have 3D 22, 3D2, 4s2, 18, 20, 22. So argon noble gas core 3D2, 4s2 is the electronic configuration of the element, second transition element, and is titanium. Come on, the fourth noble gas, noble gas, 18th group elements. So helium, neon, argon, krypton. So you have krypton. The fourth noble gas is, you have helium, neon, argon, krypton. So the krypton, which is the atomic number 36. Where you can write atomic number 36. Either you can use this former, the noble gas core, krypton 36 atomic number. You can go with electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4s2, 4p6. So this is what the noble gas configuration. Or you can go with argon noble gas core, 3d10, 4s2, 4p6. Come on, second halogen, 17th group element. First element is fluorine, the second one is chlorine with atomic number 17. Come on, write the electronic configuration. 17, neon noble gas core, 17th element. So it is a neon noble gas core, it is a 3s2, 3p5, or 1s2, 2s2, 2p6, 3s2, 3p5, which is the electronic configuration of the second halogen atom. Well, from today's class, or in this class, you have come to know regarding the guidelines to locate the position of element in the periodic table. With a few examples we practiced, and in the next class, next video, we go with periodic properties one by one.